So let's review again what you saw in the last lecture. We saw that for any counting number n and m and all non-zero real numbers a, if you have a to power n divided by a to power m, you end up with a to power n minus m. And you saw examples in video logs where if this was 6 and this was 2, you did 6 minus 2 or 4. All right, well, we're not done playing yet. We're now going to look at what happens if you have this situation. Before we had higher power of 6 on numerator and the lower power was on the denominator and we canceled. We can still do the same thing, right? But before we go into the definition, if our observations are correct, we would have to do this because that's what we've been doing. We take numerator power, there are two tens on top, 6 on the bottom, and we subtract. However, you're going to end up with a -4 as an exponent. How can we make sense of a negative exponent, which we haven't seen before? So we're going to have to spend a little time understanding what it means to have a negative exponent. Because we know positive exponent means take that many copies of the base and multiply together. Well, if it was just 4, I know I'm going to have 4 copies of 10. But what is that negative going to affect? How is that negative going to affect the base? So let's move that to the side for now, and let's go back to our drawing board and the definition. What we have is 10 squared is 2 tens, 10 to the 6 is 6 tens, so we're going to cancel our tens, and you have 1 on the numerator, right? 10 times 1 times 1 will give you a 1 on the numerator. What about the bottom? It's going to be 10 to the 4 because 1, 2, 3, 4. So this is what's going to happen when you cancel like terms. And suddenly here is a relationship that is jumping right out at you, isn't it? 10 to the -4. 4 copies of 10, which is correct. But the negative exponent means that the copies of 10 are sitting in the denominator. So we have 10 to the -4 as being 1 over 10 to the 4. This is extremely important observation. So it's very consistent with our observations before. You take numerator power, subtract the denominator power, but if you get a negative exponent, it's okay because we can make sense of it. How do you make sense of a negative exponent? It is still taking that many copies of 10, but if it's in the numerator, you're going to have 10 copies of 4 in the denominator. Well, does that work for this? Then what if you have a negative exponent on the bottom? How can we make sense of that? Say 1 over 10 to the -4. Remember, we're going to draw back when we were looking at fractions and numbers before. We looked at how you could multiply numerator denominator of a fraction by the same number. So I'm going to multiply numerator denominator by the same number, and it keeps the fraction intact like before. Remember how we did that? But now we also know how to multiply. 1 times the number is the number itself. How do you multiply these? Well, we would have to add the exponents, isn't it? That's what we were saying before. If you do that, look what happens. And we already saw that 10 to the 0, we're going to define it as 1. And so you end up with 10 to the 4 as being 1 over 10 to the -4. 10 to the -4 becomes 1 over 10 to the 4. This is an important observation. In other words, base raised to a negative exponent becomes positive exponent in the denominator. This is an absolutely important observation that's going to come over and over again handy to you. Another way to look at this would be if you have a base to a positive exponent in the numerator, it's the same as saying a 1 over base to negative exponent. Visualize this. Pause the video here and really visualize this and make an imprint of that in your head before you move forward. So base to negative exponent means what? Take that many copies of the base, but in the denominator, if you have a numerator power. If you have the negative power in the denominator, then take that many copies of the base, but in the numerator. All right, let's see how that plays out then. We would write that observation as if n is any counting number, then we're going to write a to power -n equals 1 over a to power n. A to power n will become 1 over a to power -n. So this is the observation that we just studied with that example. So to actually evaluate 3 to the negative second, how do we do that? 2 copies of 3, which is 3 times 3, 9, but a negative exponent will give you 1 over 9. So 3 to the negative second would be 1 over 9. We'll work with this more when we do the next module and arithmetic of objects. All right, so in this video log set question, I really want you to just identify what's the base and what's the exponent. So go. Pause the video if you need to. Just what's the base, what's the exponent? That's all I want you to identify. If there are multiple bases in the problem, then make sure you have all of them. Always go back if you missed any of them.